Down the air lanes they've come, down the years, the enemy on wings. How do you stop them? How do you keep them from bombing your carriers, wrecking your fleet, or ruining your defense installations? There have been adequate air combat weapons and well-located places to base them. And there have been better and better warning systems. But always there has been the probability that a sufficient number of attackers would get through to do the damage. And today that probability is much, much greater because of speed, blinding speed. Even with plenty of advanced warning and the ability to put adequate interceptors into the air from well-located bases, the odds have gotten greater and greater that the interceptor pilot, the minutes, sometimes only seconds that he has an attacker in range, will not be able to bring down his target. Vital decisions concerning course and altitude that will place him in the right position at the right time must be made in an instant, and the possibility of human error is great. And any miss is as good as miles of destruction. There's another problem that must be solved. But as in the past, there's another answer, too. Now, this airplane, being used as a test vehicle, is equipped with a new, completely automatic air-to-air armament control system, the ACS Aero X-16A. It consists, first of all, of a modified AN/APQ-42 radar, an ACD Aero X-4A computer with an angle of attack indicator, and the system uses a modified G3 automatic pilot. The ACS Aero X-16A is a completely integrated system to which a pilot can turn over his controls for those vital split-second decisions, a system that will do his computing and firing for him. When the heat's on, he takes off. He's guided to the approximate target area by means of the Combat Information Center, CIC. When the target appears on his cockpit radar indicator, he locks his radar on it and turns the ship over to automatic control. Thereafter, the system tracks the target automatically and accurately and flies the airplane, compensating for the target's evasive action. Within range, it will fire rockets or guns and break away in order to avoid collision, at which time the pilot retakes control of the airplane. No sweat, as they say, excepting the usual perspiration. It's quite an ace to have up your sleeve when you're dealing 50,000 feet off the deck. But let's go back and start over. That went pretty fast. There we are. Now, let's take it step by step. Here's what this latest armament control system does, and here's how it does it. When a plane is alerted and leaves its carrier, it is first guided into the target area by means of information transmitted from the Combat Information Center to the pilot. At this point, the interceptor's own radar is brought into play and operated in search position until the target appears on an indicator scope in the cockpit. This indicator screen is the C-scope. It's one of the two screens located in the cockpit. The second is the B-scope. The radar used here is a 250 kW set, which in the search or intercept position searches a positionable sector 30 degrees in elevation by approximately 150 degrees in azimuth. This is accomplished by means of a rectangular motion of the antenna as a whole, while the antenna dishes are knotted through an angle of 7.5 degrees. Now, after initial detection of the target, a more detailed inspection of the sector should take place. To do this, the C-scope cursor is positioned over the target with a hand control, and the radar is switched to the acquisition position. In acquisition, the scan pattern of the antenna is reduced to 15 by 30 degrees, and the cursor which directs the antenna may be even more accurately positioned over the target. Thus, the pilot is able to point the antenna within a degree or so of the target heading. With this accomplished, the pilot changes the mode of his radar once more, this time to the searchlight position. This gives him direct control of the antenna, which no longer scans but follows the motion of the hand control. In this mode, the range gate sweeps outward. When it encounters the target, it locks on. And further, by locking of the acquisition button, the range gate commences automatic tracking of the target. However, should the target now being tracked not be the correct one, the pilot simply jogs the range gate switch causing it to continue to sweep out. In fact, the pilot can at any time return to search position. After acquiring and locking on the target, and while the radar is automatically tracking the target, the information it acquires is fed to the computer, and from there to the radar C-scope. These signals show the speed and direction of the target and the intercepting plane itself. The upper line, by means of its length and direction, shows the speed and direction of the bomber, and the lower line, the speed and direction of the interceptor. With the help of these signals, the pilot can determine what type of attack to make. From the location of the movable end of the bomber line with respect to constant G overlay lines on the scope, the pilot decides whether to make the curve of pursuit attack using 2 3/4-inch FFAR rockets or 60-20 bullets, or whether to make a straight line rocket attack. If he selects straight line attack, he sets in rocket time of flight, and the computer will arm and fire the rockets when the time to go reaches 0. On the other hand, if the pilot selects a pursuit course, he also selects a range at which breakaway from a curve of pursuit course will start. With this much out of the way, the pilot is ready to select one of 2 methods of control. Since the computer supplied with radar information is already presenting steering errors on the C-scope, the pilot may simply fly the airplane manually by manipulating its controls, so that these errors on the C-scope go to 0. In this way, the pilot is the link in the loop between the radar and computing systems and the controls of the ship. However, in most cases, the pilot will choose the primary method of control, which employs completely automatic operation, with signals being fed from the computer directly to the autopilot, eliminating the pilot in the loop. Right here, with automatic operation, the pilot's a passenger, but he's a very observant one. After selecting completely automatic operation and engaging the autopilot, he can ascertain whether or not the aerial problem is being solved by watching the time to go indication, upper left-hand bar on the C-scope for a straight line attack, or if the attack is pursuit by watching the range to breakaway point, upper right-hand bar. If all is well, he just sits tight. If not, he can go over immediate to manual operation. In straight line attack, a fraction of a second after the ship's rockets are fired, the computer sends signals to the autopilot to break the plane away from its interception course. Simultaneously, red indicators light up to the right of the B and C scopes. A G limiter limits the pitch acceleration, and the roll limiter limits the roll angle as the pilot takes over control. If the pilot had selected a pursuit course, he would also have selected a range at which breakaway would start. In this case, the aircraft would be automatically flown on a straight line course until about 15 seconds before the missile time to go is 4 seconds. At this point, the ship would go into a modified curve of pursuit, completing this curve 15 seconds later with the 4 seconds of missile time to go remaining. For any value of time to go less than this 4 seconds until breakaway, the pilot may fire his rockets or guns. When the point of breakaway is reached, the plane automatically avoids collision with the target by the maximum distance, and the pilot assumes control. With manual control, pilot in the loop, the operation is similar, except that, as has been pointed out, the pilot flies the plane by correcting errors presented to him on the C-scope. In this mode of operation, there would be no automatic breakaway. Instead, at the breakaway point, the breakaway indicators light up, the signals to the C-scope are reversed, and the pilot, still keeping his steering dot to center on the scope, causes the airplane to break away so as to miss the target, again by the maximum distance. It is important, too, to note again that were the ship in completely automatic control with the autopilot engaged, it would be possible to disengage and fly manually, as has been shown, at any time during an attack. Essentially, though, omitting the variations that permit good versatility in the system, the cycle is get into the target area by means of the Combat Information Center, CIC, bring system radar into play in the search position until target appears on the C-scope. Position C-scope cursor over target with hand control and switch to acquisition position. With closer examination of target now possible, position C-scope cursor more accurately over target. Change radar mode to searchlight position, permitting direct control of antenna. Range gate sweeps outward and encounters target. Lock on target by locking acquisition button. Automatic tracking of target begins. Check C-scope. Determine tactical situation and maximum curve of pursuit acceleration necessary. Decide whether to make straight line or pursuit curve attack. And set in rocket time of flight or range at breakaway, depending on kind of attack plan. Engage autopilot, thereby going to completely automatic operation. Watch aerial problem being solved on C-scope. Plane will arm, fire, and break away, and that's it. The pilot retakes control of the ship. His target is hit and going down. He's kept an enemy out of a vital zone. His job is done automatically with the ACS Aero X-16A fire control system. If danger comes, this system, which can be used in any high-performance fighter, will greatly increase the effectiveness of interceptor defense and protect better against attack because it's a fully automatic system with greater accuracy and consequently a much higher kill probability. It enjoys this advantage in all-weather day and night action, for straight-line interception from all quarters and for pursuit attacks. It employs both guns and rockets for weapons and utilizes a G limiter in the autopilot to limit the pitch acceleration during breakaway so as not to damage the aircraft or harm the pilot. In addition, the autopilot can be used as a relief or maneuvering autopilot. For the old questions, how do you keep your enemy from bombing your carriers, wrecking your fleet, or ruining your defense installations? And for the new problem of speed, the X-16A fire control system is an answer in the jet age.